So here pretty much summarize the steps, figure out how much product was going to form on the electrode. The first thing is actually you want to know how many electrons you have provided to your system. So you can just convert the number of electrons to number of mole of electrons. And once you got that figured out, you want to know how many products I can produce from that many mole of electrons. Once you figure out that, you multiply the formula weight of that product, then you can get the mass of the product. It always starts from the amount of electricity you have provided into your system. And the question is always asking you the mass of your product in the end. The first step is to calculate the amount of electricity. The way you calculate is actually very simple. You will always tell you, okay, what is the current provided in your question? Multiply the amount of time and make sure it's actually in seconds. By doing this simple calculation, the m times seconds, they give you the number of electrons you are going to inject into your electrode. And then you want to convert this number of electrons into number of moles of electrons. So in order to achieve that, actually divide the charge you got by the Faraday constant. By doing so, you can get number of mole of electrons. Based on the balance equation, you will see how many electrons you will need for the product. Okay, so there'll be actually a conversion here. So you can actually know how many of moles of product will be produced. Okay, once you figure it out, then just multiply the molecular mass or the formula weight of your product. Then you can get the answer. Here actually summarize for each single step how the conversion was actually happening. Okay, so the first one is just m times seconds. They give you the charges. So the charge is divided by the Faraday constant. They give you number of moles of electrons. And then you want to know for one mole for a product to form, how many electrons are going to be transferred. That's why you need the number of mole of electron transfer happens. And at the very end, you actually just multiply the number of mole of product by the formula weight to get the final mass. Let's just go through one example. Aluminum is actually produced by electrolysis of its oxide dissolved in a molten cryolite. Okay, calculate the mass of aluminum that can be produced in 1 day in electrolytic cells operating continuously at certain current, where the formula weight or molecular mass of the aluminum is certain numbers. What are the keywords here? The first keyword you see here is actually electrolysis. Every time you see this electrolysis, the first thing you want to calculate is actually what is the number of electrons got produced. So the way you calculate the charges that you can provide is the m times seconds. So the m here is actually 1.0 times 10 to the 5th power. And then it says you want to actually operate this electrolysis process for how long? So you're looking for the information about time. So it says 1 day, but you know you need to actually multiply the things in seconds. So we know 1 day is 24 hours, 1 hour is 60 minutes, 1 minute is 60 seconds. Then you know that's the charge that you're going to provide it through this process. So if you do these things, you're going to get a number of 8.64 times 10 to the 9th power. The next thing you want to do is actually want to convert the charges into number of mole of charges. So the number of mole of electrons you're going to get will be the charge divided by your Faraday constant. So they will give you the charge is actually 8.64 times 10 to the 9th power. Faraday constant will be 9.6485 times 10 to the 4th power. So if you do the calculations, you are going to get a number of 8.95 times 10 to the 4th power. So you're going to get that many more of electrons. The next thing is actually you want to know what will be the product you're actually looking at. The product of this reaction is aluminum. So here you have Al2O3. You have Na3AlF6. So you want to actually see what is the charge species you have originally. So what is the oxidation number of your Al in this compound? Okay, so here you know you have 3 oxygen, right? Oxygen is always -2. And you have 3 of them. So that's -6. And then the overall is balanced. Therefore, you know your aluminum is actually 3 plus. Similar things here. Okay, you know your F is -1. You have 6 of them. Sodium is always +1. You have 3 of them. Therefore, you know here your aluminum also 3 plus. Even though here you have multiple species, but you know the ionic form of aluminum inside this question is always 3 plus. So once you see that, you know it has to be aluminum 3 plus, gain 3 electrons that give you aluminum solids. Therefore, you will know the number of mole of electron transfer for this reaction will be 3. Since you know how many electrons you are going to provide it here, okay, therefore we can actually calculate the number of mole of aluminum is going to equal to the number of mole of electrons divided by the number of mole of electron transfer in this reaction. So that will equals to 8.95 times 10 to the 4th power divided by 3. And then it will give you a number of 2.98 times 10 to the 4th power. Therefore, you know you are going to produce that many more of aluminum. Therefore, the mass of your aluminum will simply equals to the number of mole of aluminum times its formula weight. Number of mole of aluminum is 2.98 times 10 to the 4th power. The molecular weight is 26.98. Therefore, you're going to produce 8.04 times 10 to the 5th power. If you can actually get the idea, you should always start from the number of charge you're going to provide it. Then just follow this simple concept. You should be able to actually calculate the mass of your aluminum.